Alkynes. Let's look at the characteristics of alkynes on this flowchart down here. This formula describes any alkyne consisting of one triple bond and only carbon and hydrogen atoms. They are unsaturated and are part of the aliphatic group of hydrocarbons. There are straight chains and branched chains. Let's look at the first member of the family called ethyne, UPAC name, or acetylene, the common name. Here's the molecular formula, structural formula, condensed formula. Not so different in this case. Models show that at the triple bond, the molecule is linear. The carbon atoms next to the triple bond cannot be at any angle other than 180 degrees. That's why alkynes cannot have geometric isomers. Acetylene deserves a brief mention as it's so common and important in oxyacetylene torches. The green tank contains the oxygen and the red one the acetylene. The next member is propyne with 3 carbons. Molecular formula, structural formula, and condensed formula. As with propene, there's only one spot for the triple bond in propyne. It's the same molecule when written like this. It can be called 1-propyne or prop-1-ine. The third member is butyne. Here is its formulas. Again, it can be written like this, but is still the same molecule. Since the triple bond can be written on carbon 2, we must show the bond's location in the name. Hence the 1-butyne or but-1-ine. This one is 2-butyne. The nomenclature follows the same principles as previously shown in alkanes and alkenes, so we need show only 2 examples. How would you name these? Both have halogen substituents. Here's the first one. The numbering started on the left side so that chlorine would have the lower number, 1. From the other end, chlorine would be 4. In the second case, the numbering had to start on the right side as determined by the position of the triple bond, making it a 1-butyne. Chlorine now is obliged to be number 4 this time. Finally, a reference to the title page picture. This lamp is burning acetylene to produce light for the writer. It uses calcium carbide and water that react to produce acetylene gas, which is then ignited to produce a flame. Such lamps were used in the early 1900s for lighting in buildings or as lighthouse beacons and headlights on cars. They were important also for miners who carried them in mines or used them on their headgear. The man is pouring water into the container to get it started. I'll end the video with a short clip of this operation. This takes place in Estonia.
No niin. Elikkä tuo hana on 4 tuolla kotona. Saat tuolla...